At this point, our code is poorly structured and does too much at once. We have come to what's sometimes called the point of saturation. Everything becomes dependent on everything else. Changing one bit of code requires changing near everything and becomes so difficult to modify that the cost of any change outweighs the benefit. In order to make future work much easier, we need to restructure our source code to reduce interdependency. Ideally, making a change to one bit of code should require little to no changes to any other. To achieve this, we break up the source code into modules. Each module has its own specialized responsibility and nothing else. Kicking off proceedings, we'll delete the existing .class files and begin creating our new folder structure. Source code will go into the source folder and compiled class files will go into classes. Next up, we'll further organize our source folder into packages. Our first package will be called com.LetsCode. We'll now move our lesson01.java file into the new package and rename it to startup. Now, as is fast becoming tradition, we need to once again go back to our build script and make it smarter. Not only do we need to inform it of where our new source code is going to be and where it should put the compiled classes, but it also has to handle many source files instead of just one. To do this, we'll make use of the script command for. In our case, we need it to enumerate all our files in our source folder and add their names and paths to a text file. We then pass this text file called sources.txt to the Java compiler. And finally, once our class files are successfully generated, we need to update the call to the Java runtime so it knows where to find them. And now our refactoring work can begin in earnest. We begin by looking at exactly what each piece of code does and asking ourselves the question, does this belong in its own module? Well, our original implementation rendered a window with a sprite moving across the screen and bouncing off the edges, all done in an update and draw loop. As such, we subdivide each of these steps into its own Java class. The window goes into a GameWindow class, the canvas into a Canvas2D, the sprite draw into Sprite2D, and the movement and bounce into BounceExample. The update and draw loops into the Game2D class. To place it all on screen, we need some kind of transform class. We could start out with just an offset along the X and Y axes, but I decided to skip all that and go straight for a full 3D matrix. The 4x4 algorithm should serve us well into the future without having to be rewritten. To connect it all together, we make use of a design pattern known as entity component. The way this works is we keep a list of entities, and each entity has a list of components. Each component can then exhibit a custom behavior. Applying this to our example, we shall have a single entity with a Sprite2D component for drawing the sprite and a BounceExample component for its movement.